So this video clip is on project time management, and it's on the critical path method. And I'm assuming that you're already familiar with how the critical path method works. Let's talk about some further development of that. So just as a reminder, this is a schedule network diagram, also known as a precedence diagram, as distinct from an arrow diagram. It looks quite different, but arrow diagrams aren't around anymore. It's precedence diagrams that we do. This would be a common way of showing the network diagram. You can see in the legend in the upper right that for each task we have a duration of that task. Let's say it's in days. And in the network diagram we have done a forward pass, starting with task A, starting at the beginning of day 1, the early start, going through to the early finish of F at the end of day 25, and so on for all the other tasks. And we've done a backward pass, starting from finishing F at the end of day 25. That's the late finish, and we go back to all the tasks, working out the late finish and the late start, and it works back to A, which in fact has a late start of 1. Having done the forward pass and the backward pass, we look at the difference between the early date and the late date. We call that the float or the total float, and we have that in the upper right-hand corner of each task box. And if we find the tasks that have 0 float, we would say that the path that connects those tasks is the critical path, and we often indicate that in red. Now we could also have near critical path, like the path in the network diagram alongside me, from A through C to F would be a near critical path because there's only 1 day of float. We might indicate that as red and treat it as if it's critical. Let's move on. So we've been talking about float. And what I've been talking about so far is total float, which might also be known as total slack. The critical path method literature mainly calls it float. Microsoft Project and some other sources call it slack, but they're the same thing. Here's the definition. It's how long can that task or activity, I use those words interchangeably, how long can we delay it from its early date without delaying the project? Without delaying the project finish. That is the total float that we looked at in that previous slide. But there's also the concept of free float, and I think it's worth discussing because the project management software shows both kinds of floats. And I don't want you to ever be in a situation where you ask what the float is, or you see a column that defines float, but it's the wrong kind of float. So I'd like to draw to your attention there's also free float. Free float, as you see, is the amount of time the activity can be delayed without delaying any other task or any other successor task, same thing. Now, there is a bar chart is going to come up alongside me in a moment. And this bar chart is going to illustrate that, in fact, there are 2 kinds of float, and there are 2 ways of showing float. And I'm going to ask you which is the free float and which is the total float. Now, beware, the bar chart I'm going to show you is one that I have constructed specifically for the purpose of this discussion. In real life, you would not structure your bar chart like this. It would just confuse people. But this is a real network, and it is a real bar chart that I have generated. So there's 2 ways of showing float, as you will see. The one way is with the number that's in the column. Now, that column, by the way, is normally where you would have a duration. In this case, it's not duration. The column on the right-hand side of the tasks is one of the types of float. And the other kind of float here is shown as the black line after some of those blue bars. There's a long black line after some of the blue bars suggesting that that task could slip. It's one of, that too is one of the floats. And I want you to think about which is the free float and which is the total float. While you're thinking about that, I'd like to draw to your attention that on the extreme far left of this bar chart, I have the work breakdown structure because I always like to emphasize work breakdown structure. The left-hand column is the WBS number, and in the actual task list, you'll see the indenting, which also shows what that work breakdown structure is. So you've had a moment to think about which is the free float and which is the total float, and I will now reveal to you that the column with the digits is the free float, and the black line or skid mark is the total float. Now there's two reasons that we could determine that. I'll give you the longer one first. Let us look at one of the examples. Let us look at 1.5 pre-purchasing. And let's look at the first four activities there from 1.5.1 to 1.5.4. And there's obviously some logic here. Now in this bar chart, I turned off the dependency arrows. Dependency arrows are not shown, but it's evident to you where those dependency arrows are in most cases. So we're going to spend a few days doing specifications and bid documents for a generator set. Then apparently we're going to go to the marketplace to tender it, in other words, solicit prices. Then it looks like we're going to spend a day making an award of a purchase order, and then 1.5.4, somebody is going to round up a generator and ship it to us, and that's going to take about 2.5 months. Now, if those are in sequence, then if 1.5.1 specification was to slip, it would also push out tendering, an award, and generator. So clearly, 1.5.1 has 0 days of float. Similar for tender, similar for award. So evidently, the column is the free float. Now, look over to the right at the schedule bars. And all of those tasks, specs, tender, award, and generator, they've all got a skid mark of about the same length, about 2.5 weeks. So apparently, we don't need the generator until I guess that's early September. We don't need the generator until 2.5 weeks later than it could be delivered. So the specs, the tender, the award, and the generator all could slip 2.5 weeks. They have 2.5 weeks of total float. If you want to know the details, the generator, if I was to turn on the dependency arrows, you'd see that the generator has to be received by the milestone 1.6.6 equipment ready date. So that's the difference between free float and total float. I do experience that in real life people get confused between the two, but you will never get confused. Total float is the one that's most useful. We might also occasionally talk about free float, and that's a clear difference between the two. Oh, I said there was a second way that you could tell, and it's much briefer. Your free float would never be more than your total float. Hence, the column would have to be the free float. Now let's talk about schedule compression. Schedule compression is if you want to make the schedule shorter, what can you do about it? And we're going to talk about schedule compression as a critical path function or discussion. And in fact, we're going to look along the critical path. It's the critical path that defines when you're going to finish the project. And if you want to shorten the project, then clearly you have to start with shortening the critical path. Now, there's two ways that are talked about in the critical path method literature. One is fast tracking. This means overlapping the logic, doing work in parallel that you would normally do in sequence. Now, is known as fast tracking, as distinct from another method that's talked about in the critical path method literature, which is crashing. Now, crashing means shortening the duration of the activities. And there's another implication to the word crashing. The implication is that there's a trade-off between cost and schedule. That by doubling the number of people working on your task, you're probably not going to be as efficient. There's going to be more communication involved. It's probably going to cost you a little bit more. Or if you have people working 16-hour days on your task instead of on 8-hour days, again, they're going to be less efficient. It's going to cost you more. If you decide to, instead of having your own people do a task that'll take 2 weeks, you've decided to send it out to a supplier and they're going to use their people to do it in a week, that may cost you more. So crashing means shortening the duration of a task, but the implication is that there's a trade-off of cost versus schedule. Now, frankly, in fast tracking, there could be that trade-off as well. Fast tracking may be a little less efficient, and it may cost you a little bit more. Now, is there another method that's completely different way of compressing a schedule that we should always be able to think about when responding to a request to make the schedule shorter? Well, yeah, that way is to see whether the scope can be reduced. Are there any tasks that can be deleted? Maybe schedule is more important than scope. So maybe we will, in agreement with management or customer, remove some items of scope. So for example, we're not going to get the building project finished by freezing weather. So maybe we take the landscaping package and we remove it from this year's project and we do that next year in a subsequent project, just as one simple example. But let's stick with fast tracking and crashing now. And I'm going to ask you, if you do fast tracking or crashing, what do you have to look out for? What are the dangers to look out for? Well, there's several things. You will find that when you shorten the critical path, which is the obvious place to start, other paths will become critical. As you shorten the critical path, another path will become critical. Now, to get additional schedule compression, you're going to have to shrink both those paths. Then you're going to find a third path becomes critical. It's going to become more and more difficult. So that's one answer. Other paths become critical. Well, we've already identified cost could go up. For crashing or fast tracking, there may be less efficiency and costs may go up. Quality might go down. If we've got people pushing for schedule achievement to speed things up, maybe the quality of the work is going to decline. Not necessarily, but maybe. It's certainly something to look out for. Risk goes up. Now, it's various kinds of risks. The fact that maybe now you're going to end up with 3 critical paths instead of 1 means that the project is going to be a lot harder to manage. And there's additional risk that you won't meet the schedule completion date. With a more relaxed date, maybe there was a high chance of meeting it. Now, with a tighter date, there's less chance of meeting it. Other kinds of risks may go up too. I guess the risk of quality, or if it's a construction project, safety-related risks may go up. Morale may go down if you're pushing people real hard and having them working longer hours. And speaking of people resources, you may have a resource over-allocation. If you've got 2 tasks, both of which require carpenters, and now you're overlapping them instead of doing them in sequence, you need more carpenters. Or if you're doing crashing, and instead of having 2 carpenters, you're going to have 5 carpenters, well, maybe you don't have 5 carpenters. So you might be allocating more resources than you actually have, and we call that resource over-allocation. Now, let's do a crashing exercise. And in the notes that accompany this video clip, there is a table that says crashing. And the assignment for you is to decide how will you shrink this project by 3 months. This is not a trick question. The numbers that you see here in this network diagram, in fact, are in months. You want to save 3 months on the project duration. Now, when we're doing crashing, The implication is we're probably doing it, we're making choices to do it as cheaply as possible. And so how can you save 3 months on the project duration at the cheapest possible costs? Which tasks will you shorten the duration of? Now let me just take you through one line of this table so that it's clearly understood. The wording here might seem a little bit clumsy, but it's that way because I wanted to be completely consistent with the project management literature. So task F, the original duration, the duration right now is clearly 14 months. The crash duration, it says, is 12 months. So it could be shrunk by 2 months. That would be a time saving of 2 months. The original cost, in other words, the estimate right now is $10,000 for task F. The crash cost, in other words, the cost if F was to be shrunk by 2 months, would be $14,000. That's $4,000 of extra cost for 2 months, or $2,000 per month of saving. Now, one other tip I'll give you is that if this table says you can shrink a task by 2 or 3 months, you could prorate it and shrink that task just by 1 month if you choose to. So I'm going to leave that question with you. You might like to put this video clip on pause, do that calculation, and we'll get right back to it. So you've looked at the crashing exercise, and I'm wondering where you did your shrinkage of tasks. I did set up this exercise so that there was a trap in it, and I'll say what that is in a few minutes when we get there. Where is the cheapest possible month along the critical path? Well, first, where is the critical path? Clearly, the critical path goes through F. It's A, F, G, H, C. So it goes through F. The cheapest month clearly is H. So let's shrink H from 3 months down to 2 months. That's as far as we can go with H. That only costs us, by the way, $1,000. That's as far as we can go with H. We can't shrink H anymore. Where is the next cheapest month in this network diagram? Well, some of you might say B. We can shrink B by a month for only $1,500. Are you going to do that? No, you're not going to do it. B is not on the critical path. We're not going to shrink B. It wouldn't do you any good. Where's the next cheapest month along the critical path? Well, it's F. Let's shrink F by 1 month from 14 down to 13 months, and that's cost you $2,000. So what's our next month? Some of you may have been tempted to shrink F by 2 months. So you'd shrink it down to 12 months and pay another $2,000. Are we going to do that? No, we're not going to do it, because now that you've shrunk F by a month, B and D are also critical because they're 13 months. So you have 2 critical paths now. If you shrink F, you're going to have to shrink B or D. Okay, where's the next cheapest month? It's G. You can shrink G by 1 month for $2,500 and take advantage of the project shrinking by a month. So you have shrunk it by 3 months, and it has cost you $5,500. I'm wondering whether that matched what answer that you came back with for that exercise. I have a feeling you did. Congratulations. But this reminds us that when you do crashing along the critical path or fast tracking, other paths will become critical. So this picture that you see alongside me is to help me make the point that rather than you, the project manager, or you, a project planner, doing all of the scheduling and then providing your schedule to the project team, Get your project team involved in the scheduling. There's a number of project management exercises and tools that we should get our project team involved. You will find that you get a better result if you get your team involved in work breakdown structures, critical path scheduling, risk identification and response. You're going to get more people contributing. You're going to get a better result. You're also going to have their involvement, so it's providing some motivation. And also, they're all going to learn more about the project and be more functional at carrying it out. And you're going to find that later on when you're doing project controls, people aren't going to throw up their hands and say, well, I didn't think that was a realistic schedule in the first place. Now it is their work breakdown structure and their schedule. This particular exercise with Post-it notes and critical path networks I've been doing for more than 20 years in scheduling of projects. This most recent one was done with in a client's office with whiteboards, but when we run on the whiteboards, we have plastic films of plastic that adhere to the wall with static electricity. They're kind of a portable whiteboard extension. You see that here. My colleague and I came prepared. We'd spoken with the project manager, and we came prepared as outside facilitators to facilitate the critical path. We came prepared with the work breakdown structure already printed out on address labels, put on 5-inch by 5-inch Post-it notes. And I was there at the front of the room, in front of the project team. They were building the network. I was just the facilitator, moving stickies around at their direction and drawing lines. So after about a half a day, we had a full network diagram prepared for the project. The whole project starts at the extreme left-hand side that says environmental assessment approved. I know that you can't read the font on these stickies, but the details don't really matter. We have several paths of the network. Off to the right of the screen is where the project all comes together in some milestone that says project completion. We made a point that there are no dangling paths. All paths all do come together at the end in that one milestone. In some cases, the pre-printed sticky has a duration on it in days. In some cases, we put the duration on or revise the duration in the room. We also thought of new tasks or milestones that we added into the critical path network and that would get added into the work breakdown structure. In most cases, we used straight finish-start relationships. But you may be able to see that there's some finish start with a lag of 5 days. There's a finish, and other dependencies are in use. Now, we know that a schedule is a planning tool. But a schedule is also a control tool. It's something that we compare the project to and that we use to report progress and to forecast whether or not we're going to achieve the completion date. So thinking of it as a control tool, I'm very pleased in this particular example to have embedded a sophisticated control device into this critical path schedule. What is it? Yes, you're right. It is the thermostat on the wall that I had to work around when building my critical path network diagram. Just kidding, but after all, a thermostat is a control device. It doesn't just measure the temperature of the room, it takes action to correct the temperature of the room. Similar to schedule control. When you're controlling a schedule, you're not just measuring whether or not, how things are going and comparing it to the baseline. We're also taking action to try to keep the schedule on track while we're carrying out the project. So as I say, I've had success at team building of schedules and other project management tools and deliverables. This has actually been published in the project management literature. It's called, well, usually commonly known as the yellow sticky process. I recommend if you're going to do it, be prepared in advance. Have your work breakdown structure. Maybe you've already worked out the work breakdown structure with your team, for example. Come prepared with, therefore, with the activities at the bottom of the work breakdown structure. Have thought about constraints, must be finished by a certain date, and so on. Can only work a 5-day week, other things that might be constraints. Think about how many resources, what resources you have. And if you can, think about individual activity durations. in advance if you can. Then, as a group, you create the network. You can probably do it in a few hours, if not less. And when you do have it in front of you on the whiteboard, do a quick count and figure out where the critical path is. You can figure out where the critical path is without having to do a full forward and backward pass. It will come out at you. And then you can calculate that and say, oh, this network is a year and a half. Does that make sense? Would this kind of project normally take a year and a half? If we think we should be able to do it in a year, this is our opportunity. The team is right there. Let's try to do some crashing and fast tracking to find ways to shrink that. Then we put it in our project management software. When I'm facilitating this kind of schedule, I've got a colleague in the corner typing it all into project management software such as Microsoft Project. At the end of the exercise, he or she and I work at polishing up that Microsoft Project file, and then we can give it to the project manager for some further development and improvements, and then present to stakeholders and for approval. So this is the end of this video clip on Critical Path Method Part 2.